Hey everyone, welcome back to the channel. Today, we diving into a term that gets thrown around all the time in the tech world, API. What is it, and why is it so important? I remember the first time I heard someone say a PI, I just nodded along, pretending I knew what was going on. It sounds super technical, right? But the core idea is actually something we encounter every day, just in a different form. So let's break it down. What does the PI stand for? Application Programming Interface. Okay, that probably doesn't help much yet. Let's forget the words for a second and think about a real-world problem. Imagine you're running a massive logistics company. You've got ships, trains, and trucks all over the world, moving goods from one place to another. Now, think about the containers they carry. They're all a standard size, right? They have specific dimensions, and the points where a crane lifts them are always in the same place. This standardization is crucial. It means any crane at any port can lift any container from any ship and place it onto any truck. You don't need a special crane for a specific company's container. This universal standard saves an unbelievable amount of time and money. It makes the entire global shipping system work efficiently. In the world of software, an API is exactly like that standard for shipping containers. It's a set of rules and definitions that allows different software systems to talk to each other. It's like a universal language they all agree to speak. When one program wants to get information or ask another program to do something, it uses the API. The API defines exactly how that request should be structured. What information does it need to send? What format will the response be in? Let's say you're using a weather app on your phone. That app probably doesn't have its own weather satellites and thousands of weather stations. Instead, it uses an API to ask a big weather service, like the National Weather Service, for data. The app sends a request through the API, saying, "Hey, I need the current temperature for New York City." Because it follows the rules of the API, the weather service understands the request and sends back the data in a predictable format, like 72 degrees Fahrenheit sunny. The app then takes that data and displays it nicely for you. Without that API, the app developer would have to build a custom one-off connection to the weather service's database. This would be incredibly complicated, expensive, and fragile. If the weather service ever changed its internal systems, the app would break. But with an API, the weather service can completely overhaul its backend systems, and as long as the API itself doesn't change, your weather app will keep working perfectly. The API acts as a stable, predictable middleman. This brings us to another important concept that's closely related to APIS, the contract. If the API is the standard for the shipping container size and lift points, the contract is the agreement about what's inside the container and how it's handed over. In software terms, an API contract is a more detailed agreement. It specifies the exact data formats, the types of requests you can make, the possible responses you can get, and even error codes for when things go wrong. Think of it like ordering food at a restaurant. The menu is the API. It tells you what you can order, the functions you can call. The contract is the unspoken agreement that if you order a burger, you'll get a patty between two buns, not a bowl of soup. And if they're out of burgers, the waiter, the API response, will tell you, "Sorry, we're out of that," which is like an error message, instead of just staring at you blankly. This contract ensures both sides know exactly what to expect. For developers, this is a game changer. It means you can use a service without needing to know anything about its internal complexity. You don't need to know what programming language it's written in, what kind of database it uses, or how its servers are configured. You just need to read the API documentation, the manual for the API, and follow the rules. This massively reduces the cost of integration. It allows developers to quickly piece together different services to build new and powerful applications. It also makes systems more resilient. Imagine your application relies on a specific map service. If that service suddenly shuts down or becomes too expensive, you're not completely stuck. As long as you can find another map service with a similar API, you can switch over with relatively minimal changes to your code. You're just swapping out one standard component for another, like changing a light bulb. The API is the standard socket that lets you plug in different brands of bulbs. This idea of standardization is the foundation of modern software development. It's what allows thousands of different apps on your phone to connect to the internet, get notifications, use your location, and interact with each other seamlessly. But here's a thought-provoking question to leave you with. If standardization is the whole point of a P is to make everything interchangeable, then why does the entire tech industry seem to be obsessed with specific APIs, like the one from OpenAI? Why is everyone scrambling to build on their specific interface if the goal is to be interchangeable? That's a fascinating paradox, isn't it? It's because while the concept of an API is about standardization, the capability offered through a specific API can be unique and revolutionary. OpenAI's API isn't just a standard way to request data. It's a gateway to one of the most powerful artificial intelligence models ever created. The value isn't just in the plug. It's in the unprecedented power source it connects to. Developers aren't just using a standard interface. They're tapping into a unique, groundbreaking ability that wasn't available before. So when a new, powerful technology emerges, its API becomes the de facto standard, not because of some international committee, but because it's the only door to that new capability. Everyone rushes to learn that specific API to build the next generation of applications. Over time, competitors will emerge, and maybe even offer similar APIs, creating a new standard. But for now, the race is on to master the interface that unlocks the future. So to recap, an API is a set of rules that let software systems talk to each other. Just like standard container sizes, let the global shipping industry work together. It's a contract that guarantees predictable requests and responses, dramatically lowering the cost of building and maintaining software. And while the goal is standardization, a truly revolutionary service can create its own must-have API that everyone wants to connect to. I hope this helps demystify the term API a little bit. It's a simple idea with incredibly powerful implications. Thanks for watching, and if you found this helpful, don't forget to like and subscribe for more tech breakdowns. See you in the next one.